In this video, we are looking at solving systems of linear equations, specifically looking at how to do this using algebra. So when we are solving systems of equations, what this means is that we have two or more equations of lines, and we want to figure out what x and y pair, what pair of numbers would work in both or all of the equations. And typically there's only one answer for this. There's one x and y that will work in all of the equations. And we're going to look at two different methods of solving this algebraically. We're going to look at substitution and elimination. So first of all, solving systems of equations using substitution. To solve by substitution, what we're looking for is we want to solve one of the variables, and then we're going to substitute that into the other equation. So our first step is to pick one of the equations, and we're going to solve for either x or y. Doesn't matter which equation, doesn't matter x or y. The more you do of these, the more strategic you'll get in deciding which equation to choose and whether x or y. Essentially, we're looking for the easiest one to get by itself. Then you're going to substitute that into the other equation to solve for the remaining variable or the remaining letter. And then we always want to check our answer. So for example, if I have these two equations here and I want to solve using substitution, I'm looking at both of these equations and I want to find the x or y that's easiest to get by itself. And the one that's sticking out to me is this one here, because it's already by itself in terms of it's not attached to a number. So I'm not going to end up dividing by anything, which means I'm avoiding fractions. So that x is the one I'm going to solve for. So I'm going to take that equation, x minus 3y equals 6, and I'm going to solve for x, or get x by itself. To do that, I'm going to add 3y to both sides. And so I get x equals 6 plus 3y. So now I've solved for x. I've gotten x by itself. I'm then going to, step 2, substitute that into the other equation, whichever equation you didn't use. So the equation I didn't use is 2x plus 3y equals 3. And I'm going to substitute 6 plus 3y in for x. The reason I've done this is because now I have no more x's in that equation. I only have y's, which means I can figure out and solve for y, just like I would if I'm solving linear equations. So the first thing I'm going to do is expand this bracket. Remember that this 2 is going to apply to my 6. It's also going to apply to my 3y because of our distributive rule. So 2 times 6 is 12. 2 times 3y is 6y. So I get 12 plus 6y plus 3y equals 3. I can then combine or collect my like terms. So I get 12 plus 9y equals 3. And now I want to get the y by itself. So I'm going to subtract 12 from both sides in order to get rid of this 12 here. So I get 9y equals negative 9. And then I'm going to divide each side by 9 to get the y by itself. And I get y equals negative 1. If you are struggling right now with understanding how I solved for y, I strongly suggest going to look at one of my other videos on solving linear equations and work on solving linear equations first before you jump into solving algebraically here. Because if you're struggling with solving and solving for y, you're going to end up kind of struggling through all of these steps. So just take a pause here if you are not sure how I solve for y there and that really confused you in that step. I highly suggest you do some work on solving linear equations before coming back to this video. Okay, so now I have my y, and I can solve for x. Doesn't matter which equation you use here. I'm going to use the equation I used in step 1. And I'm going to substitute y equals -1 in this equation and solve for x. X plus 3 equals 6. So I'm going to subtract 3 from both sides, and I get x equals 3. So again, in step 1, I am I'm picking one of the equations and solving for one of the variables. I then used that in the other equation to essentially get rid of my x's so that I can solve for y. And then I substituted that into one of my equations to figure out what x is when y is -1. And so our final step is to check. And a lot of people skip this step, but it's super important to make sure you haven't made a calculation error somewhere along the way. Again, remember, our main goal, what we're trying to do when we're solving these systems of linear equations, is we're trying to find an x and a y that works in both equations. So in order to check our answer, we're just going to check, does it work? Does it work in both equations? And if it does, we know we did it right. So I'm going to take x equals 3 and y equals -1, and I'm substituting that into my first equation, and I'm checking to see if my left-hand side and right-hand side match up. So I get 3 plus 3 equals 6, or 6 equals 6, so it worked there. And my second equation is 2 times 3 plus 3 times -1 should equal 3, and I get 6 minus 3 equals 3. So 3 equals 3, and I know I did it right. So it doesn't take long to do a check. I strongly encourage not skipping that step and just taking that extra second to make sure your answer is right. So our final answer is x equals 3 and y equals -1. So here's another one for you to try. I want you to pause the video, try this out, and then start it up again when you're ready. Okay, so our first step is to solve for one of the x's or y's. Now, looking at this one, there's none in particular that stand out as being maybe easier. The only one possibly is this 2y, just because I know I'm going to end up dividing by 2 to get the y by itself, and fractions over 2 aren't that bad to work with. And so I'm going to choose to solve for that one. But again, it doesn't really matter. You'll get the same answer in the end. So I have minus 5x plus 2y equals -4. And I'm going to get y by itself here. So I'm going to add 5x to both sides to get rid of my -5x on that side. So I get 2y equals -4 plus 5x. And then I'm going to divide by 2. So I get y equals -2 plus 5 over 2x. So my second step is I'm going to substitute that into the other equation. Make sure here it's very important you use the equation you did not use in step 1. And I'm going to take -2 plus 5 over 2x and put that in for y. If you've done this step right, it means that you should only have one letter left. And so I only have x's left. So I know I'm on the right track. And I'm going to solve for x. So I'm going to expand this bracket first. Again, remember the 6 applies both to the -2 and the 5 over 2x. So 6 times -2 is going to get me in -12 here. And then 6 times 5 over 2 is going to get me a 30 over 2 or a 15x equals 3. I'm then going to combine my x's, so I get 25x minus 12 equals 3. I'm going to add 12 to each side, because I'm trying to get my x by itself here. And then I'm going to divide by 25 and simplify. So 5 goes into both of those, and I get 3 over 5. So x is 3 over 5. So now I'm going to substitute 3 over 5 in for x in one of my original equations. So that I can solve for y. And so I get negative 3 plus 2y equals negative 4. I'm going to add 3 to both sides. So I get 2y equals negative 1. And then divide by 2, I get y equals negative half. And finally, step 4 that we don't want to skip is to check our answer. Does 3 over 5 and negative 1/2 work in both equations? So I'm going to substitute this in. To my first equation. And my left-hand side equals my right-hand side there. And then I'm going to substitute it into my second equation. And see if my left-hand side and right-hand side match each other. So 10 times 3 over 5 is 6. And then 6 times 1/2 is going to be minus 3. So it does work out. So I know my final answer is x equals 3 over 5 and y equals negative half. Last one to try using substitution. And I'm looking for which one is maybe going to be easiest to get by itself. And this y is standing out to me in the second equation there. So I'm going to rearrange this equation to get y by itself. So I'm going to subtract 6x from both sides. I get minus y equals 1 minus 6x. And then I'm going to divide or multiply by negative 1 in order to get the y to be positive. So I get y equals negative 1 plus 6x. My second step is going to be to substitute that into the other equation. And again, you know you've done this right if you only have one letter left at this step, which in this case is my x, which is good. So I'm going to expand that bracket. I get minus 3 plus 18x, because remember the 3 applies to both. I'm going to combine my x's, so I get 20x minus 3 equals 7. I'm going to add 3 to both sides to get 20x equals 10, and then divide by 20 to get x is half. I'm then going to substitute that into one of my equations to figure out y. So 6 times 1/2 minus y equals 1. 3 minus y equals 1. So minus y equals 1 take away 3, or negative 2. So y equals 2. So I subtracted 3 from both sides here, and then I multiplied or divided by a -1 in order to get my y to be positive. And our final step that we're never skipping is my check, just to make sure. So we get 2 times a half plus 3 times 2 should be 7. So we get 1 plus 6 equals 7, or 7 equals 7, so it works in my first equation. And then 6 times a half minus 2 should be 1. 3 minus 2 is 1, or 1 equals 1. So I know I did it right. Okay, the other way we can solve these is by using elimination. So it's a slightly different method than using substitution. When we're using elimination, what we want to do is we want to first make sure our equations are in standard form. So in ax plus by equals c form. Then we're going to make either our x's or our y's the same number. The sign doesn't matter, the same number or the same coefficient. So we're going to multiply one or both of the equations in order to make their x's and y's the same. Then we add or subtract in order to get rid of or eliminate one of those variables. And then after that, the steps are the same as substitution. We substitute it back into one of the equations to get the remaining variable, and then we check. So it's going to be similar to substitution in terms of step 3 and 4. What changes is the first 2 steps. In substitution, we are getting a variable by itself and substituting that into the other equation. In elimination, we're making the number the same so that we can eliminate that variable. So let's look at an example. So here, instead of looking to see which variable I can get by itself, I'm looking at my x's and I'm looking at my y's, and I want to see, is there one that has the same number, or is there one that I can easily make the same number? And in this one, I see that my y's both have a 3 in front. So that first step is sort of already done for me. My y's both have a 3. One is positive, one is negative, that's fine. I'm just looking at the number. My next step is to add or subtract them in order to get rid of the y's or have the y's cancel out. So in this case, I have a negative 3y and a positive 3y. This is where we look at those signs. And so if I was to want to get rid of or have them cancel, am I adding those numbers together or am I subtracting? I'm going to add, because negative 3y plus a positive 3y is going to give me 0y. And so I'm going to add these two equations together. So I'm kind of like thinking of this in columns here, and I'm adding as I go down. So x plus 2x gets me 3x. Minus 3y plus 3y gets me 0y. And then 6 plus 3 gets me 9. So if you've done this correctly, either your x's or your y's will have a 0. If you still have a number in front of your x or y, you haven't done it properly. So what this leaves me with is 3x equals 9, meaning I can solve for x. So I'm going to divide both sides by 3, and I get x equals 3. That is essentially those first 2 steps we did in substitution. Right? I've already got my x is 3. My step 3 and 4 are the same. I'm going to substitute x equals 3 into one of my equations. In order to solve for y, I'm going to subtract 3, and I get minus 3y equals 3. And then I'm going to divide by a negative 3, and I get y equals negative 1. And finally, I'm going to do a check to make sure that I've done it correctly. So I get 3 minus 3 negative 1 should be 6. 3 plus 3 equals 6. So 6 equals 6. It works in my first equation. And 2 times 3 plus 3 times negative 1 equals 3. 6 minus 3 equals 3. So 3 equals 3. Works in my second equation. So you can see how, depending on the situation, elimination might be a little bit quicker than using substitution. Let's try another one. So I'm looking at my x's, I'm looking at my y's. Is there one that's the same? No. I have a 3x and an x, and a 2 and a 3, y. So those aren't the same. So I'm looking, is there one that I can easily make the same? And what's standing out to me here is my x's, because I can easily make an x a 3x by multiplying by 3. If I was to choose my y's here, I can't multiply 2y by something to get to 3 or 3y by something to get to 2 without having some really funky fractions going on. And so I would end up having to multiply both by something in order to get them to both be like 6. And so it's easier if I'm just having to do it to 1. But you would get the same answer in the end. So it doesn't really matter. You're just trying to pick the one that gives you the least amount of work. So what I'm going to do is I'm going to take this second equation and I'm going to multiply it by 3. Now we have to multiply the whole thing by 3, not just our x, or else we've changed our equation. We don't want to do that. We need to multiply and make the whole thing 3 times bigger. So instead, I end up with 3x plus 9y equals 6. So now my two equations are 3x minus 2y equals 4 and 3x plus 9y equals 6. There's my two equations. So I've multiplied one of my equations to make my x's the same. Now I need to decide adding or subtracting. So I have a 3x and a 3x. If I add those together, I'm going to get 6x, which doesn't help me. I want to get 0x. So I'm going to have to subtract the two equations in order to get a 0x there. So 3x minus 3x gets me 0x. Be careful with your negatives here. Negative 2y minus 9y gets us minus 11y. So we have to be really careful when we're subtracting with negatives. Okay? And then 4 take away 6 is going to be negative 2. So I'm left with minus 11y equals negative 2. And so I've eliminated my x, which is my goal, and I know I'm on the right step. And I'm going to keep going. I'm going to divide by a negative 11, so I get y equals 2 over 11. I can now substitute that into one of my other equations. So I get 3x minus 2, 2 over 11 equals 4. 3x minus 4 over 11 equals 4. So I'm going to add 4 over 11 to both sides. And I get 3x equals 48 over 11. And then I'm going to divide by 3. And I get 16 over 11. Now our final is to check to make sure we have done that correctly. So 16 over 11 minus 2 over 11 should equal 4. I get 48 over 11 minus 4 over 11 equals 4. Get 44 over 11 equals 4, or 4 equals 4. And 16 over 11 plus 3, 2 over 11 equals 2. 16 over 11 plus 6 over 11 equals 2. So 22 over 11 equals 2, or 2 equals 2. So I know I did it right. Now you'll notice throughout this problem, I kept them as a improper fraction. And this is just to help with when I end up checking and adding and subtracting fractions, then the bottom number stays the same. They're both over 11, so it makes my adding and subtracting a little bit easier. But if you want at the end, you could state your final answer as a mixed number in its lowest form. Okay, so here's another one. I want you to pause the video, try it out, and then start it up again when you're ready. Okay, so again, I'm looking to see which ones would get me the y's or the x's the same the easiest. In this case, both would be fairly easy, but let's look at making this 2 into a 4x by multiplying this whole thing by 2. So I get 4x minus 12y equals 24. Remember, you need to multiply everything by 2. And 4x plus 12y equals 8. And so I'm looking at the fact that both are positive 4, so I'm going to subtract the equations in order to get rid of my x's. So I get 0x minus 12 is negative 24y. And then 24 minus 8 is 16. So minus 24y equals 16, or y equals negative 16 over 24. And we can simplify that. They both have 8 that goes into them. So minus 2 over 3. Now I'm going to substitute that into one of my original equations. We're always going back to our original equation. So negative times negative is positive. 6 times 2 is 12, divided by 3 is 4. And then I'm going to subtract 4 from both sides. So I get 2x equals 8, x equals 4. And then finally, we are going to check to make sure that it works in both. So I get 2 times 4 minus 6 times negative 2 over 3 should equal 12. I get 8 plus 4 equals 12. 12 equals 12. So that one's good. Let's check our second equation there. 4 times 4 minus or plus 12 times negative 2 over 3 should equal 8. So 16 minus 8 equals 8. 8 equals 8. So I know we did it right. So our final answer there is x is 4 and y is negative 2 over 3. Okay, let's skip down to some word problems. And we're going to solve the system of equations algebraically, meaning that you're welcome to use substitution or elimination, whichever one works best for you and works best for the question. The tricky part of word problems is coming up with the equations, because you haven't been given the equations. You need to come up with them based on the situation, and we want at least 2. So, a person's email for a week contained a total of 103 messages. The number of spam messages was 4 more than twice the number of other messages. How many were spam? So the first thing we want to do is determine, well, what is our X and Y's going to represent? So what are the 2 things that we're sort of comparing? We're comparing spam messages and other messages. So let's let X equal spam and Y equal other. We're going to give ourselves a little legend there, a key, so that after we're done all the math, we can remember which was which to start with. So now that we know what X and Y represent, we're going to come up with 2 equations to help us solve this out. So let's read through each sentence again and see if we can come up with an equation to represent that sentence. So a person's email for a week contained a total of 103 messages. So total tells me I'm adding, so I can do X plus Y equals 103. So spam messages plus other messages is 103 messages. The next one says the number of spam messages. So spam messages is X. Is 4 more than twice the other messages. So X equals 4 plus 2Y. 4 more than twice the number of other messages. How many were spam? So now that we have our 2 equations, we can decide whether substitution or elimination would work best here. Because we already have an X equals, we can use substitution here. It's already done our first step. So let's look at substituting X equals 4 plus 2Y into our original equation. So we get 4 plus 2Y plus Y, so there's our X, plus Y equals 103. And I can combine my Y's here, so I get 4 plus 3Y equals 103. I can then subtract by 4. And I get 3Y equals 99. I'm going to divide by 3. Y equals 33. I'm then going to substitute that into my original equation in order to now solve for X. So I'm going to subtract 33 and I get 70. And we can check our work. 70 plus 33 should equal 103, and it does. And 70 should equal 4 plus 2 times 33, which is 4 plus 66, which is in fact 70. So I know I did it right. Now with a word problem, we always want to finish off with a word answer. So therefore, there are, it asked how many spam. Remember, spam is X. So there are 70 spam messages. Is our final answer there. So with word problems, again, the tricky part is coming up with the equations. But if you can first figure out, well, what do my X and Y represent? And then use the sentences to write some equations. And after that, you're solving using substitution or elimination, depending on which one is best for you or for the question. So I want you to try this next one. Pause the video, try it out, and then start it up again when you're ready. Okay. Customer ordered 3 cups of coffee and 4 cups of tea. His order came to $9.90. The next customer ordered 5 cups of coffee and 3 cups of tea, and her order came to $11. How much is a cup of coffee? How much is a cup of tea? So first thing, what are X and Y? Well, X can be the price of a coffee, and y can be the price of a tea. Those are the two things we're trying to figure out. So that can be my x and y. So let's read through the question again and come up with some equations. A customer ordered 3 cups of coffee and 4 cups of tea, and his order was $9.90. So we could say that he ordered 3 cups of coffee, so 3 times x, plus 4 cups of tea, and it came to $9.90. The next customer ordered 5 cups of coffee and 3 cups of tea, and it came to $11. So there's our two equations, and we are going to solve for x and y. So substitution-wise, we could use substitution, but we're going to be dividing by some funky numbers. So it might be easier to do elimination here. I'm going to give us some more room. And we need to figure out how we can use elimination. So x's and y's, neither one's particularly easier than the other. But I'm going to do my x's here. I'm going to multiply this first equation by 5 and the second equation by 3 in order to get both of my equations to be 15. So I end up with 15x plus 20y equals 49.5. That's my first equation multiplied by 5. And I get 15x plus 9y equals 33 if I times my second equation by 3. And because my 15s are both positive, I'm going to subtract my equations in order to get rid of my x's. So 15x minus 15x is 0x. 20 minus 9 is going to be plus 11y. And 49.5 take away 33 gets me 16.5 or 16 and a half if you want to work with fractions. So I get 11y equals 16.5, y equals 1.5, or we can say $1.50 because we know we're working with money here. So now I'm going to use that to figure out what my x is. So again, I'm using my original equations just in case I made a mistake in my multiplying there. I'm going to do 3x plus 4 times 150 equals 990. So 3x plus 6 equals 990. I'm going to subtract 6 from both sides, and I get 3x equals 390. Divide by 3, and I get 1.3 or $1.30. So now I'm just going to do a quick check to make sure that I did it right. So I get 3 coffees, so 3 times 130 plus 4 teas, and I should get $9.90. So that one worked out. And let's check the second customer. Did 5 coffees and 3 teas. It was $11. And it works out. So again, we want to write our final answer in words. So therefore, a coffee is $1.30 and a tea is $1.50. Let's try one more using some percentages. So a hospital invests $10,000 into 2 different funds. After 1 year, the rate of return is 10% on the first fund and 12% on the second fund. The total interest earned is $1,068.50. How much was invested into each fund? So our funds can be our X and Y. So we'll say our X is the first fund and our Y is the second fund. Let's reread the question and see if we can come up with some equations. So a hospital invests $10,000 into 2 different funds. So we could say X plus Y is 10,000. After 1 year, the rate of return is 10% on the first fund. So we can write 10% as 0.10x. That's going to tell me how much interest is earned on the first fund. And I'm adding that to 12% on the second fund. And it's telling me my total interest earned is $1,068.50. So I'm using those percentages as a decimal. You could also use it as 10 over 100 or 12 over 100 if you wanted to use it as a fraction. But we can't just use 10 and 12 because that would 10 times the amount I invested, which is not accurate when we're looking at interest. For this one, I'm going to use substitution because I can very easily get x and y by itself in that first equation. But again, if you used elimination here, you'll get the same answer. So I'm going to first look at x plus y equals 10,000. So that means y is 10,000 minus x. And I'm going to substitute that into my next equation. So 0.10x plus 0.12, 10,000 minus x equals 1,068.50. I'm going to expand my bracket. So 0.12 times 10,000 is 1,200 minus 0.12x equals 1068.50. I'm going to combine my x's. So I get 12,000 minus 0.02x equals 1068.50. And then I'm going to subtract 1,200 from both sides. I'm trying to get my x by itself here. I get negative 0.02x equals negative 131.5. And then I'm dividing both sides by negative 0.02. And I get $6,575 for my x. I'm now going to substitute that into one of my equations. I'm going to do the first equation. So I get 6,575 plus y should get me 10,000. So y is 10,000 minus 6,575, which is 3,425. And we're just going to do a check. So 6,575 plus 3,425 should equal 10,000. And it does. So we know we did that one right. The real test is the second equation here. It should work out to 1068.5. Which it does. So therefore, $6,575 was invested into the first fund, and $3,425 was invested into the second fund. Okay, so I want you to rate yourself on how you have felt about solving systems of equations algebraically, both using substitution and elimination. So thumbs down if you're having trouble solving systems of equations using algebra and you need some help, a finger pointed if you need some more practice, and a thumbs up if you're like, I've got this, I can solve systems of equations using both substitution and elimination, including the word problems, and I don't need any more help or practice.